Hi, Thibaut.
Hello, Alan. How are you?
I'm great. Very nice to see you. So,
Great.
today my guest is Thibaut Vidal. He holds the Scale AI chair in data-driven supply chains and is professor at the Department of Mathematics and Industrial Engineering of Polytechnique Montréal, Canada. He's also a member of CIRRELT and an adjunct professor at PUC-Rio, Brazil. His main domains of expertise relate to combinatorial optimization, heuristic search, and interpretable machine learning, with applications to logistics and supply chain management, production management, resource allocation, and information processing. He's the author of over 50 articles in reputed international journals and conferences, such as ICML, OR, Transportation Science, SIAM Journal on Optimization, Pattern Recognition, and Informed Journal Computing, among many others. His work has been recognized by various prizes in different scientific societies. He serves as associate editor for the journal Transportation Science. Thibaut is a great friend and co-author of mine. And a little fun fact here, apparently I'm his most popular co-author according to Scopus. So Thibaut, it was about time to have you here. Merci beaucoup. Thank you so much. Ça va? Tudo bem?
That's so fantastic to finally be part of this stream of videos and to make this interview with such a good friend. And indeed, you have been some of the most prolific co-authors in our respective careers. Made a lot of papers in common.
Yeah, absolutely. I'm so looking forward to having this conversation with you. So you were originally from Fontainebleau, in France, right?
Yes, Fontainebleau. So it's my birth city. This is a small city that is south of Paris, more or less 40 kilometers from the capital. And there is a very beautiful forest around, a lot of rocks for climbing. It's a very nice place. It's a very nice place to grow up.
Great. You are actually my first French guest. And you're also the first guest who's younger than me. Yeah. So how was life growing up in the 80s and 90s in France?
Well, 80s is not like I spent that much time in the 80s. I think it was a fairly standard way of growing up, at least from my perspective. Nothing so out of common, fairly quiet life. I moved a few times when I was young in different cities. Also close to Dijon, which is a place where there is a lot of wineries and the cultivation of wine. And also close to Chambol-Musigny for people who like wine. Then came back to Fontainebleau, and that's it, more or less.
Okay. So before joining school, you learned many things from your mother. Can you talk more about this?
Oh, yeah. So my mother, she worked as a teacher, and she was extremely enthusiastic and supportive to teach me a lot of things when I was young. So jointly with my mother, also with my cousin, I learned how to read, for example. So I never actually took a class of reading. They told me a lot of stuff, and then they left it to my intuition. And with trial and error, I kind of got it. Well, it was a bit self-taught and a lot of contribution from my mother and my family.
Yeah, so how did you deal with the fact that you were younger than your classmates in school? Because you mentioned that you learned things back home, and then when you joined school, you were a little bit advanced, and you were placed in a class with senior students.
Oh, yes, that's true. So one of the consequences of learning to read faster is that basically there was an entire level in class that was not really useful for me anymore. So I kind of skipped what we call the CP, which is more or less when you are 5 years old in France. And I ended up being a little younger, a little smaller than the other students in class. And I think this kind of rule, it followed me during a lot of my like young age, always being a little smaller. But what I could not do in terms of maturity or sport or whatever, I tried to compensate by studying a lot and and doing my best, basically.
Yeah, right. You read The Hobbit, which is that famous book by Tolkien, at a very young age. And how that book influenced you? Because I remember you were talking a lot about that book when you were reading when you were growing up.
Yeah, so I love to read, and it's part of the things that my mother and so on, they taught me. And they left me with a lot of curiosity to try to get better at reading and be able to read stuff that were more complex and so on. I don't remember exactly when I got that book. I think I was not that old, perhaps 7 or 8. I'm not sure I got the entire story. I could read through the book. I loved it. It's like it's a fantasy world, Tolkien. There is so much stories with elves and giants and stuff that happens. It's a fantastic world to grow up. I really loved it. And then I followed up reading very regularly fantasy and things like that. That's kind of the style of things I love to read.
Yeah, I see. I know you used to play piano during your childhood and teenage years. Was it just a hobby?
That's another very big part of my early life. So I started piano when I was fairly young. It was the fault of my cousin, Caroline. She took classes of piano before me, and she's older than me, like 5 years older. And I saw her training, and I wanted to do the same. You know, like children, they love like to imitate their siblings. In my case, it was my cousin. And I took up with piano, trying to kind of bit compete with her. But then I really found something that I loved in piano. I spent many years training and playing up to when I was 18, basically. And piano is a marvelous thing. You can share all your moods, your feelings. You just transmit it through music. And whenever it's a good day, a bad day, you will always have a way to express yourself with piano. That's really amazing.
Yeah, I know you play really well because I've seen you playing here at my place the last time you visited me.
We improvised. I remember that thing. That was a bit crazy.
Yeah.
That was very nice, actually.
Yeah, we had a lot of fun. Yeah, playing together. It was great. I hope we can do that one more time or multiple times in the future.
Definitely.
Yeah, and you went to a preparatory school in Paris. Tell me how the system works and how was your experience?
Oh, so preparatory school in France is a very different world. I'm not sure every country has this system, but those are like 2 or 3 years that you spend before getting access to what we call Grandes Écoles d'Ingénieurs, engineering school in France. And those are basically preparation years for competitive exams for the entrances of these schools. And it's a lot of math. It's very heavy teaching load. You get really, I think, 30 hours in class per week, plus a lot of extra work overnight. So it really tests your ability to kind of overwork yourself. I cannot say that I remember everything of what I learned in preparatory school because just too much content. But the thing that you learn is a kind of methodology of work. You know that you can take a huge workload on your back, that you can carry through this, and this stays during your life quite a bit. I mean, it's more a training of being efficient, but in itself, you don't remember that much after the experience.
Yeah, you learned many things, but you forgot them very fast too.
Oh yes, exactly. That's so. It's really quick to forget when you learn a lot of stuff together.
Yeah, you also told me you were not very good in math, and you also did not have very good grades in general. How far that is really true?
Well, I will not say that I was bad, but it's true that I was quite average in math in high school. I never got something like top marks I think in math I was like 14 out of 20, 15 out of 20, nothing exceptional at all. But I loved puzzles. So I had part of the logic. Sometimes I was making stupid mistakes. I was not always attentive enough. So perhaps it didn't play in my favor. But over the end, with regular training, it was possible to develop that, getting better, and so on. So it's more a question of focus, I think. To be good in maths, you need to be very, very careful, not making any mistake, and remembering everything in the right way. That's really important.
At some point, you had to pick a career. How was the process in your case?
A lot of things that happened to me, I would say that it was really like based on luck in some sense. You never predict what you are going to do in the future. So, for example, I finished my preparatory school and I ended up in NCMAG in Grenoble, which is a school specialized in computer science. It was one of the top schools that I could get based on the ranking that I had from the competitive exams. And I absolutely loved the teachings. In particular, all the disciplines that I got in operations research from my professors, introduction to operation research and so on. And then later, the course by Denis Dadef, they were really outstanding. And I got a very good taste and very good impression of that discipline. But as I told you, I was not an outstanding student at all at that time. I didn't have the focus of really learning very carefully everything. And there is two possibilities on that year at the NCMAG. You could go either towards something that is more oriented towards industry and something that is more towards research. And I ended up in a fork road without a clear idea in mind of whether I would like to do something that is more academic or not. The only thing that determined my choice was just a chance of events. I was in the tram just coming back from the university, and I crossed one of my professors who was called Julien Moncel. And he was one of the professors who made kind of projects that were like research focused. And he told me, well, have you considered going to the academic side of the classes? And I say, well, I'm not that great. I don't have the grades. I'm not sure I can actually pass and go in this direction. He told me, you can try. It's going to work. I say, okay, I'm going to do on academy and research, then something like that. And that's exactly how it happened. It was just a random conversation that led me to something that I clearly like. It was perhaps one of the best decisions of my life because I love this area.
So like it was by pure chance that that opportunity came up, and you just took it, and the rest is history.
Yeah, things happen like that very often in life. You never calculate everything.
Right. But before we continue, during the first year, you were quite busy, first year of university, but playing a lot of video games. Tell me more about that.
I get very distracted. So I'm a bit of, I would say, I focus on stuff. So when I was young, I focused on piano, I focused on reading, and then I had my game period. So I really focused on gaming during a couple of years. And I lost a lot of time, I think. Looking backward, it's a bit sad that I spent that much time playing at the moment that was crucial in my life. So I actually missed a lot of content in some classes that I had to catch up later. It led me to have a very unfortunate grade in graph theory, for example, because there was an exam which was calling to some notions that had been seen during the class. There was a special graph with a certain name, and in a subject, it just recalled the name of the graph. And I didn't know what was that graph because I was not attentive. I didn't carefully work, and I got a horrible grade because I was trying to figure out what is this graph. I have no idea what is K44 or something like that. I don't remember. It was something like very, very basic, but I didn't have the notation. I didn't know what it was all about. And yeah, I got a very bad grade.
Right.
And then the thing is, coming back to being focused, my focus changed after that. When I found my way, I really found like, oh, I like research. I like operation research. That became my focus for several years. And I really did my best to do that properly. That's the way I work mentally.
We are all aware of that, yeah. So you mentioned Professor Denis Dadef at just now. What is the importance of Professor Denis Dadef in your academic career?
Well, Denis Dadef was my professor for the linear programming classes and some of the operation research classes that were taught at Grenoble in the NCMAG. And is brilliant for branch and cut and all mathematical programming techniques. He's extremely well known internationally. And that's again a change of events somehow. At the end of the master, when we are in France, well, we do a lot of classes. On the research part is not that big. It's just 6 months to do the part of research of the master in these kind of courses in France. And I really wanted to go abroad. I didn't know where I wanted to go. I wanted some experience that was not in France. So I saw like Canada. Canada is exotic. There is probably bears or something very, very different from what I know. And I asked the INADEF, do you know someone in Canada? Tell me, yes. I have good contacts with researchers in Montreal. I can indicate you. I say, yeah, that's perfect. That's how I came to Montreal. So without the INADEF, I would never have made the connection to here.
Yeah, so I went to Montreal in 2009 doing your master's.
Yes, my master finished in 2009. So the 6 months of the research were in 2009. And it was with Theo Kleinig and Michel Gendreau. And we started basically work on vehicle routing and genetic algorithms and things like that.
Yeah, but apparently you got confused when meeting a particular professor there in Montreal.
Yeah, that's kind of a story. So I didn't know where I was stepping in. I was not aware that like CIRRELT, where I was being received for my internship, was such a famous laboratory for transportation. I didn't know all the names and how important all these people were. So for example, I arrived and Theo, he told me, you are going to work on vehicle routing. I said, vehicle what? I had no idea what was vehicle routing about. I had to learn everything. And again, I loved it. So that's something I really liked. But I think what you are referring to, a slight mistake of name, it's this story where the first time I arrived in CIRRELT, there is this entrance. That's the first time I was opening that door. And there was a coffee machine. I went there and I saw a professor. I introduced myself. Hello, I'm Thibaut. I'm new intern here, doing some kind of research period in Montreal for 6 months. Nice to meet you. Who are you? He told me, I'm Professor Gendron. I said, oh, you are my advisor. It's Michel Gendron, my advisor. It's Mr. Gendron, my advisor. And he stopped a few seconds. I think he was thinking, I don't have someone coming today. No intern that is planning to arrive from France today. And so he told me, maybe you have made a mistake. But your name is Gendron. My professor is Gendron. Is it different? Oh, yes. There is Michel Gendron and Bernard Gendron. So I actually met Bernard before Michel. I really thought it was my advisor at first glance.
That's a very good
one. But then I cleared the confusion.
Yeah. So how did you come up with the idea of coding a genetic algorithm for a VRP variant?
So that was the idea of Theo Kleinig and Michel. They were building a very large project that was about doing a kind of cooperative search for variants of vehicle routing problem that included like multi-depot, multi-period, and combination thereof. And for that, they wanted basically several solvers to cooperate through a central memory. So they wanted a taboo search to be coded, they wanted a GA to be coded, and there were some integrators, and we had to put all of this in parallel. So I was in charge of the genetic part, and they basically told me, start by re-implementing the famous GA of Christian Prince, because it's a very good algorithm for the standard capacitated VRP, and then try to extend it to other variants like multi-period, multi-depot. Do your best to address these variants properly.
Okay. At that time, you were already discussing with your supervisors and coding, but were you aware that some of them are really famous?
Oh, I think as a student at university, you never really get to realize how big, how important some of your professors are. You don't know that they have written hundreds of papers, that they are incredible researchers who spend their lifetime on their nights doing incredible papers. And I realized that a bit after I arrived, I realized the luck I had to have such great advisors.
Yeah, and apparently it took just a week for you to code the GA.
Yes, so.
And you're not really familiar with C++. I mean, you knew it, but you're not used to code a lot in C++.
Yeah, well, you know me. I'm not that great coder, but I'm very enthusiastic and a bit compulsive in what I do. So Michel and Theo, they gave me the first week, they told me, look at this paper from Christian Prince and try to reproduce it somehow. And I really took up the challenge. I read at night in my apartment. It was really like something temporary, an Airbnb that I was living in Montreal. And I have plenty of time in the evenings. So I started coding. After a couple of days, I had coded perhaps the basic local search, and it started to produce solutions.
Mm-hmm.
And I started to get really captivated, seeing the numbers. Oh, this starts to look close to the solution that I reported, and so on. And then I put the G on top of that. And the paper of Christian Prince is very, very well written. There is no space for wondering how things work. They are very clearly described. So it's like a very clear recipe of what you have to do. And it's actually not such a huge code. So after a week, it was working very well, and it was producing very good results that were almost the same as what Christian had reported in the paper. So I came back to Michel and Theo. I said, well, the code is done. They told me the code is, you mean you read the paper? No, the code is done. It's working properly. Well, they don't know how much time I spent on those days. Perhaps accumulating total, I spent like 6-7 days, 15 hours on that.
Uh-huh. Wow.
But that's doable in a week. Just a huge time investment and, well, a lot of enthusiasm, like looking the numbers. I almost remember by heart the values of the solutions of the first few instances of Christophidus.
Yeah, we all do.
I saw them repeating line per line.
Yeah, I know. yeah, I know. But then after that first implementation, you guys ended up introducing the diversity management component, which is a key ingredient and of the algorithm, and it made it very successful, later becoming the hybrid GA that solved many variants. But we'll get to that soon. But tell me, how did you have the idea and how was the process?
So the original algorithm from Christian Prince has some diversity management. It has this, but in a way that is kind of rejecting solutions if they have the same value. And this kind of prevents you from having twice the same solution in the population. It makes sure that you have some amount of diversity. But I realized that very quickly the search could still get a bit stuck. A lot of solutions would get rejected due to that component. And it was not maintaining a very high level of diversity. So it looked like there was a big correlation between being able to maintain a very good diversity in the population and getting good results. At that time, I tried to push further the method, trying to promote further diversity. And instead of setting it as a constraint, what appeared to be a very good solution was to kind of putting it as a goal, measuring diversity within the context of the population and counting it as part of the objective function with some kind of normalization strategy that is based basically on ranking the solutions. And that worked much better than the original diversity management. That was one of the key components that led to a basically more modern version of this type of genetic algorithm. And then we added a couple of other things. Exploring infeasible solutions and putting some penalties for that with this kind of oscillation strategy where the method will self-calibrate to find good penalty values. And that really helps also the method to get better solution. And the last component was better local search, like applying known techniques of granular search, restricting the neighborhood to have something really, really fast. All together, that led really to a very good algorithm.
Yeah, and that was done during the masters or only later? I mean, all the enhancements.
So say At the end of the master, the first 6 months of my internship, we had a very good working version of the generic algorithm. I cannot say that it was the final one because it still evolved a bit in the subsequent years, like 2010, 2011, but there was a very stable version at that time already.
Yeah, but that was not originally intended to the CVRP.
Oh, no, indeed. So the original goal was to cover multi-period, multi-depot vehicle routing problem. Again, by some kind of circumstances and chances, in a meeting with Michel, Theo, and also Nadia Larici, who was kind of helping my supervision, and Walter Ree, the idea came up of submitting the paper to operation research because the results were really good. Like compared to the actual literature, it was a huge step forward in terms of solution quality for multi-period on multi-depot vehicle routing problems. So we ended up submitting to operation research. And one of the first review comments that we got was, well, your algorithm looks pretty nice. It's really working very well. It's a combination of known techniques, but the combination looks interesting. We are only very curious to see how it could perform on the most classical version, the capacitated VRP. So please do the test on that. And that's how we did the test. We actually applied this algorithm that was not anymore intended for the CVRP, and we ran it on the CVRP. We compared to a very good algorithm at that time, which was an algorithm of Nagata and Brasi, and I really loved the papers from Nagata. I remember in a conference, I saw Yushi Nagata. I said, Nagata! And I ran towards him, and he was like, what? Okay, so I know your papers. And that's it. That's how we produce good results on the CVRP as well. And that was key, actually, in the development of this research. This briefly comment was essential for the paper.
Yeah, you mentioned Nagata and Oli Brasi just added me on LinkedIn recently.
Really?
And yeah, it's a huge coincidence. Right. Yeah, very nice. While you were doing the research and responding to the reviewers' comments and updating some tables in certain appendices of some reports and making other people a bit annoyed, and that's me, because I was familiar with the work, but from time to time you seem to kept on improving the results on the CVRP, and every time I was thinking, I'm finding good solutions, I'm even improving, and then for some reason months later that table from that appendix of that report was updated. But the story of that OR paper was a bit different than usual, right, in your case?
Oh yeah, it was a bumpy ride. So we started with this major revision where we had to produce CVRP results. The major revision turned into a minor revision who seemed that it was really going into the right direction. And we waited like quite almost 6 months. So we were already very far into the reviewing process. And just after that, we had a straight reject. So this reject report, it was motivated by the fact that there was new papers that were actually fairly recent or a bit different from the one we had reviewed in a paper, who seemingly were producing good results for the considered variants of the vehicle routing problem. So the report was basically saying, oh, you omitted these papers, and it seems that they contain good results that makes your contribution not so impressive in comparison to what we thought originally. And that was very weird for us. I remember at that night, I was, I think, in a kind of small conference for PhD students somewhere, and it really hit me like a truck. I wonder, how is it possible? I knew we had looked all Riven papers. So on the same night, I took all these papers, I compiled tables, I double check everything again, the result, and I was like, no way. These results don't change anything to the comparison. They are actually not even better than results that we are already comparing with. So why can't it change anything to the evaluation of the paper? And I remember writing a huge letter with the tables and everything to Theo and Michel, and saying, "Oh, doesn't make any sense, this thing. There is clearly some kind of mistake. So what should we do? Should we kind of write a rebuttal, send to the editors to consider this?" And we spent again a couple of days making a very strong letter somehow explaining that on our concerns. And it seemed that it worked out. We could revert that reject decision and get the paper finally accepted. It was very challenging to get through operation research with a meta-heuristic. It's true that operation research likes to really publish strong methodological contribution based on strong theoretical contribution, often favoring, let's say, mathematical programming work over heuristics. And that many heuristics that we design, they often relate to combinations of components. So people will object, "Oh, this is a combination of things that are known. So is it really an innovation?" You really have to tell a very good story and have very good results to motivate a new paper in OR on such a subject. Sometimes it can work.
Yeah, right. Following a PhD was a natural path for you then?
Oh, yes. Then, well, we are coming back a bit before this OR thing. So we are back at the end of the internship. And one day, Michel and Theo tell me, "Well, what do you want to do after the master? I mean, you have promising results. Are you interested in staying in Canada, doing something longer, like a PhD?" And according to my situation at that time, it appeared that it was possible to kind of spend a couple of years more in Canada, but not something too long. So we opted for something that would be a mix between a period in Canada and a period in France. And we call that the co-tutelle, where you kind of do half of the doctorate in one country and half of the doctorate in the other country. And the most logical connection that we could make was to contact directly Christian Prince, who was the author of the original GA on which we have basically built the start of this research. And Christian Prince was super happy to host me in Troyes, and we did a really large part of the research on the PhD with him and his team.
Mm-hmm. And what motivated you to generalize your hybrid genetic algorithm to other VRPs?
I remember having discussions in CIRRELT with a few people and a lot of students and professors, and everyone was kind of working on a different variant of the vehicle routing problem. And when you look at the literature, this is very often like that. Everybody is kind of working in his own little space on something that is relevant for a specific application. And it looked like such a waste of time that every time you have to do something for a new application, you have to rebuild everything from scratch, from the beginning. Even for like for production time in a company, if you have to develop an algorithm, this is a year. And then you put it in production for a specific application, it's going to really take a very long time at the scale of industrial applications. So it appeared necessary to be able to handle things more quickly and having something that would be more flexible. There was already a history. For example, if you look at Cordo work and co-authors, the unified taboo search, if you look at the ILNF of Pissinger and Hopke, even your work, Anand, with the iterated local search, there was already a vision of making methods that would be effective for several variants of the vehicle routing problem. But it was like 5, 6, 10 variants, perhaps, not a huge amount. Mm-hmm. So we took up the challenge of building something that would be extremely flexible, on which we could integrate most of the important variants of the vehicle routing problem, and something that would not kind of require to always consider all the constraints and all the objectives, and, for example, set a lot of value to 0 or dummy values, trying to have something that kind of selects the right component at the right time. It was possible due to C++ design, where you have what we call inheritance and polymorphism in some classes, and that led to a kind of Swiss Army knife, where the method would kind of take the right component for every variant, and that led to the unified hybrid genetic search, which had very good results.
You got
a lot of different variants.
Yeah, you got the best paper award from EJOR, for example, because of that paper. And then it's very, very impressive work. And I guess some PhD students at the time were not really happy about that work.
Oh, I remember that. So I had a couple of discussions with some students who had specific topics. And when they saw the unified epigenetic search, they were, oh my God, I had good results until now, and now my results are not competitive anymore. And since we were covering actually 50 variants on the first paper, I imagine that this has impacted a lot of people who were working on those specific variants at that time. So there had been a couple of occurrences where people came to me and say, oh, you made my life pretty hard during the PhD. I really was like, I'm really sorry. That was not the goal. But ultimately, we had to take that step to kind of understand all the variants of vehicle routing that could be solved together, and then also help refocusing the literature on variants that would be out of this context that are really, really very different from the rest.
Yeah. From my side, I was very fortunate to have been able to publish a year before, or a few months before. Yeah.
So it was fine.
Yeah, so I escaped. And then you compare with some of our results and all that. But it was close. It could have been...
One thing that worked out was that sometimes you see research as a competition, but it's not really true. In some circumstances, when I ended up kind of having conflicting results with some other colleagues or authors, we found a nice way to kind of join our works and do something that we would actually both profit from it. There is always solution.
Yeah, we did that.
These things, you have to talk, you have to communicate on, and I'm somebody very open. It's not difficult.
We experienced that together ourselves. So, So, right. So all your PhD efforts were paid off in the end. As I mentioned, you got the best paper award from EJOR. You shared actually the VeRoLog prize with Roberto Roberti, who was also here as a guest.
Yes.
So at some point, at that time, you also became a bit obsessed with the paper about timing problems. And I remember you talking about that quite often.
I remember in some conferences, it was a bit with you, a bit with Julien Michelet, who was a doctorate student at my time. And we were really wondering, why is it so hard to solve problem with soft time windows where the penalty function for being like early or late for a customer visit would be kind of a convex function? And compared to other vehicle routing variant, there didn't seem to be any straightforward way of checking the costs of a solution in constant time during the local search. On the other hand, there are some kind of way to relax time constraint, like following some ideas that Nagata had suggested, something that we call time warp, where you actually pay to accelerate. And this thing, it could be solved in constant time for evaluation. And it looked like quite a mystery, what we can evaluate efficiently and what is the complexity of the evaluations, considering very different time characteristics. And well, we had a start. So I started like looking at the literature in routing, found a lot of information on that. And then I extended to scheduling and find a lot of information on that. But actually the same models, you find them in resource allocation. You have some lot sizing formulation that actually are exactly the same. And the idea came to kind of make a very non-standard paper that would look more like a half survey, half unification of techniques for evaluation of time constraints in different combinatorial optimization problems. That was a very weird paper. And we call that timing problems on algorithm. It was ultimately published in Networks.
Yeah, I remember.
Was a very fun project. This was one that took me a huge amount of time in my doctorate.
Yeah, I remember that. Well, it was more or less also during that period that I met Renaud Masson, Hugues Dubedu, and Julien Michelet that you just mentioned in a conference in Metz in France. You were not there. I went with Puka to that conference. And I remember Julien told you ask for my contact after you became aware of my presentation. Because I also had some algorithm that was solving many variants, VRP variants. And then we started to exchange messages. And later we decided to assemble a team, the 6 of us, plus Vinicius Petrucci, yes. A great friend, for the ROADEF challenge. So do you remember, we had some fun, but we started well, but then the results in the end were not that good. But ultimately we were able to publish before their special issue. And I don't think they were very happy about that, but yeah, it was something.
It was not done on purpose, but it was such a fun team. I mean, we were like almost like 7 PhD students on that team of 6, all good friends. We did that method for the challenge. We are not that competitive. I mean, we were perhaps ranked 7th or 8th. Or
in the first round, we were doing well, but then in the second round, it went downhill.
Yeah, well, perhaps. But the method was fairly simple.
Yeah.
And we applied it also, if I remember, on multi-capacity bin packing.
Yes.
And we decided to, make a short paper out of it. And ultimately, if I remember well, we submitted to expert system with applications.
Yeah.
And it got the first review that was fairly decent. We did the comment. We submitted back the review.
From my place, you were here.
Oh, yeah.
We went for a snack. 20 minutes later, the paper was accepted.
Oh, yeah, that was the fastest. That was the fastest thing ever.
Yeah.
Probably the editor just handled the thing, checked, and I remember that.
Yeah, that was
our first paper, I think.
No, that was not the first one that was published.
Oh, no, that was Marcus.
Yeah, that's what I'm going to talk about it now. I usually ask the guests, well, when did you get your first paper published in a journal? In your case, I know because I was there as co-author. Of course, you had the OR journal, but that came a bit before because the revisions were taking too long.
Publication time. Yes.
Yeah. But the first one that came out was the EJOR one. So after that partnership we started, I realized that you were doing a superb work on VRPs and all that. So I thought it would be more advisable to collaborate with you instead of competing against you. So do you know that famous saying, if you can't beat them, join them? So I invited you to contribute on a research work related to the minimal latency problem, that is also known as the deliveryman problem or traveling repairman problem, with Marcus, you know him really well, and Satoru, and which ended up being published in EJOR. And as I mentioned, it was our first paper together, and also the first one that you were a co-author that appeared in a journal, right? So that was also a very nice story.
It was actually a direct application of some concepts that were developed in the timing paper. Yeah. And thanks to this research, we could cut off one order of complexity.
Exactly.
In the algorithm. We went from cubic to quadratic. That made the method 1,000 times faster.
Yeah. Yeah,
I still remember that.
Yeah, and it's still well cited, and it's a pretty decent algorithm, I would say. And also in 2012, I invited you to attend the Brazilian OR conference, which took place in Rio together with Claio. I was not living in Niterói anymore, so I invited you to stay at PUC's place.
Yes, it's true.
Yeah, so do you want to come to Brazil and stay at my friend's house? You knew him because we were collaborating in the ROADEF challenge, but it was fun anyways. So that visit changed your life.
Oh, indeed. So that was the first time I actually came to Brazil, and I was hosted at PUC's place, and incredibly welcoming and accommodating. Actually, in my whole life, I think I never paid an Airbnb in Brazil. There was always someone to host me. And that was a consequence of staying in PUC's that I met Renata at the same period, who later would become my wife. So this visit changed my life totally.
Yeah.
Indeed.
Yeah. Renata, I used to share the office with her, and also 2 other girls, Luciana and Adri. They are all dear friends of mine, very nice people. And I remember that we had a great time back then. You even convinced Vinicius and myself to attend a concert by a heavy metal band called Epica.
Oh, I remember that.
Yeah, at Fundição Progresso. And we took you and Christian Prans to the Botanical Garden with Satoru and Renata. Right?
Yes, that was a very beautiful walk. I still remember that. It was fantastic.
Yeah, we went to the Sugarloaf too, you know, so it was nice. And then the magic happened there at some point, I don't know. And I remember I was after a while when I realized that you guys were dating, I said, Renata, you should hold on to him, okay, and make him come here to Brazil. And that happened. Yeah. So, but after finishing your PhD, you started 2 postdocs, more or less at the same time in 2 different countries.
You were basically the mastermind of my coming to Brazil. You had set up absolutely everything, yes?
Yeah. That I had a big plan, so I had to calculate and pull the strings and make it happen. Yeah. But anyway, tell me about the postdocs.
Okay, the postdoc was another phase. Then, after the PhD, I had already participated quite a number of conferences, and I got in touch with, in particular, 2 professors, Patrick Jaillet from MIT and Richard Hartle from Vienna. Both proposed to me a very good postdoc offer, and they both looked super interesting as an experience. So I could not decide. I decided to cut in half, and I spent more or less half of the postdoc in Vienna, and the other half in MIT. Actually, Patrick called me a bird. He said that I was always in some other places during the postdoc, which was actually a bit true because I actually split the 2 experiences. And both were very, very interesting experiences. With Patrick, we focused on very mathematical work, very deep work on some form of resource allocation problem that led to a couple of papers published in SIAM Journal Optimization, on Informed Journal Optimization as well. And with Richard, I was less like a postdoc working alone on some topic, more as a co-supervisor, colleague role on task. So he quickly integrated me in some of his project that he had with very brilliant students. And this is the way I quickly got to informally advise a number of students from his group. For example, Peter Mattel, Ulrich Bräunig, Gerhard Hiermann. Those are all great people with whom I was lucky to collaborate right after the PhD. It was really super good experience on both sides.
Yeah, but you also spent some time working with Professor Nelson Maculan at UFRJ in Rio, in Brazil.
So that was even a bit after the 2 periods of postdoc. Nelson Maculan, who is a very important professor here in Brazil, make a lot of connection for many people. And he invited me for a shorter visit, which was, I think, 3 months long. And I think we also worked with Raphael Kramer at that time.
Yes, exactly. Yeah.
One of our also common co-authors.
Yeah.
That was the first longer period that I spent in Brazil. This longer period led to a research period at the TechGraph Institute in PUC-Rio. Mm-hmm. And in that time, it was Marcelo Gattais and people responsible for the institute that figured out the funding and managed to fund me. And this ultimately led me to a position in PUC-Rio, which is a very good private university in Brazil. It's a very dynamic research group in optimization. Yeah,
one of the top private universities in Brazil for sure. Yeah, I remember one of their visits, I also talked to Marcos Poggi to see if you could consider taking a look at your CV and all that, maybe in the future to have you there, and it happened in the end. Mm-hmm. So I remember when you got the position, you told me I was the first person that you informed, right? When you called me, yeah.
I called you very quickly.
Yeah.
Because again, you were the mastermind of all of this.
Right. In that visit, when you were spending some time with Professor Nelson Maculan, you also came to our place and you gave a talk. And you know that there were future co-authors of yours there, like Teobaldo Bulhões, Rafael Kramer, Eduardo Queiroga. They're all there attending your talk.
Yep.
They're all my former master students. And I remember I even had to lend you a pair of shoes because you forgot to bring appropriate footwear in that trip to João Pessoa. So I don't know if you remember that.
I don't remember that. This is something I don't have in memory. I had a few outfit accidents in conferences, especially one conference where it was in Italy, and my luggage got lost or very heavily delayed, and I was really with nothing in the conference. And I remember that Walter Ree actually lent me a shirt for the conference. It was a much bigger shirt than what I could fit in. But shoes, I don't remember very well that shoe thing.
Yeah, it
It's
happened.
very
Trust me.
possible.
Yeah, trust me.
It's very possible.
Yeah. Anyway, you found the position at PUC-Rio, and you work with very nice students. You want to talk more about the experience?
Well, I had also excellent collaboration with a lot of your students in Brazil and many other brilliant students in the country. Yeah? I know, for example, how careful you are at helping the student to develop their skills, programming, and then learning, operation research, and so on. And it has always been a very great pleasure to collaborate with students that you have kind of trained, and many others in Brazil as well.
Yeah. So let's switch topics a little bit. You were quite active on ResearchGate and on Twitter. And sometimes one guy or the other like to make a provocative comment about metaheuristics. And you tried to post a reply to several of them very patiently.
I don't know if I'm so patient. Some of my reply were not always patient, because people have a tendency on some forums and things to kind of take everything and put it in the same bag. So I see people that say, well, everything metaheuristic is crap. There is no theory, there is no science behind that. Go with mathematical programming. This is the things for serious people. And I say, this is not true. I mean, in practice, when you go to a company and you want to do OR applied to very complex combinatorial optimization problems, there is no way you solve that with mathematical programming, either to optimality or even heuristically to a decent size. It just doesn't scale up in many, many cases. So you will have to go with heuristics. And well, if you don't explore this side, what is the guidance, what rule we need to follow to design good meta-heuristics and heuristics. So I actually found there is amazing work on the complexity of local searches, whether it's always polynomial time, what is the number of steps for a local search to converge. Actually, like the Gary and Johnson, I think they even publish things about that, about complexity of local searches. It has been in the past something that was an important topic. But over time, the focus has shifted a bit from technical aspects related to local searches and complexity and neighborhood exploration strategies, to really the meta-heuristic side, heavily inspired by nature, heavily inspired by bees and ants and coyotes and wolves and chaotic cuckoos. And this is where things get, I would say, too weird. I think you cannot just take a metaphor like bees or whatever natural species and say this is good for optimization. We took genetic algorithm because they embed the concept of crossing solution. And crossing solution is a very technical concept that you would not need actually genetics to explain. We used the name end colony optimization, which was actually because it was early application of reinforcement learning for search. And all the metaphors that are the mainstream metaphors, they are actually nice way to express a very technical concept. Now you give me a bee algorithm where bees are actually dancing and doing something. Well, perhaps they are also crossing solutions, and they are doing the same thing. Mm-hmm. They are just writing it in a different vocabulary. So you create technicalities due to a new vocabulary, but you don't bring in a new real contribution. So my whole point in this kind of discussion is that there is amazing work being done on heuristic search. The thing is, we need a common technical way of describing these things. We should stay away from the metaphors And this is very well written in the paper of Kenneth Sorensen, Metaheuristics, the Metaphor Exposed, that I really recommend anyone to read. And we have to stay technical. And there is still a lot of progress to be done. I mean, there has been recent papers about what is the complexity of exploring for-opt for the TSP. I mean, you would always think, well, for-opt is something that is so well known for 50 years that there is no more progress on that. No, it's not true. There has been theoretical papers about that over the last 3 years. So there is still a lot of potential. I really recommend to continue in that direction.
Yeah. Do you think that certain types of work involving metaheuristics can negatively affect the reputation of the field?
But that's the problem. I mean, there has been this loophole of natural inspired metaheuristics, and the academic world is designed in such a way that you are evaluated by the number of papers that you publish, where you publish them, and so on. So making a new natural metaphor, coding it quickly, writing it in a paper, submitting it in a certain journal is a very fast process. And it's actually beneficial for several people, and you cannot just incriminate those people. I mean, this is the game we created. This is the academic system we created. So I think there has been an exorbitant number of papers published on natural analogy for metaheuristics, and I'm not convinced that those papers bring much to the theory of how to search and how to do better in terms of practical use of optimization for application and things like that. So we should somehow guide the community in the right direction. That's something I try to do as much as possible. And I hope that people just will not put always in the same bag everything metaheuristic related. This is not all about insects and other stuff. There is a very serious concept.
Yeah, absolutely. Yeah, I totally agree with you. Over the years, you decided to study different topics other than routing. Can you comment more about this?
Oh yeah, so I really spent a lot of time on routing. Even for the USGS paper, the Unified Hybrid Genetic Search, I almost spent like 6 months in my basement creating tables, compiling results, and reading instances, because of course nobody uses the same instance format. Well, actually we tried, Rory Mendoza led a project, the VRP rep, to try to fix this issue. But well, routing is huge, but you cannot do your life on routing only. There is so many other interesting problems, clustering, machine learning problems, things related even to physics, to signal processing, phase unwrapping, which is some form of Steiner tree related problems. It's good to take what you know, good optimization, metaheuristics, other techniques, and try to look at connected domains to find promising applications. It's a very important thing too.
Yeah, so you work with pattern recognition, decision trees, and other problems like that, right?
Yes, indeed. So I shifted a bit towards the machine learning domains over the last few years, because there is a lot of hidden heuristics in this area. Many methods that are developed in machine learning, they look like ad hoc procedures, like CART. CART is basically a greedy algorithm for constructing a decision tree, but it has never been really often described as such, as a greedy algorithm that is optimizing a certain objective function with a certain greedy criterion. And well, we know from the heuristic literature that there is so many ways to enhance constructive algorithm that could be attempted. So, for example, you can enhance very easily a lot of decision tree algorithm using knowledge that comes from the optimization literature. The same with clustering. If you look at k-means, which is a very famous local search from minimum sum of squared clustering problem, well, it's a very classic local search. Once you have a good local search, you can put that within more sophisticated metaheuristics. For example, within a genetic algorithm that will iteratively combine solutions and apply local search on that. That's something we did with a student of mine, Daniel Gribel, which has led to a very nice algorithm called HG means. Well, there is a huge potential to bring the knowledge that is from OR part to a number of machine learning tasks. And beyond that, there is even more than that. There is a discipline to bring. In OR, we really love to formulate models and then solve these models. This way of developing research is not systematic in machine learning. Very often, papers mix together the definition of the model and the definition of the method. They will create a model, create a method, test it for the application. But they don't really evaluate the method as such as an optimization for a certain model and, for example, looking at the objective function. And that's something I think is really important, because sometimes you have a very good model, like, for example, okay, is minimum sum of squares clustering a good algorithm for a good model for clustering? Well, I will only know that if I have a good method for that model. So if I stop with a very simple local search for it, I may not have the good conclusions about the ability of this model. So using the OR reasoning, decomposing, formally stating the models, studying different methods for that model, possibly some exact methods, some heuristics, verifying how far these heuristics are for these models, I think that's something we can really bring and further stimulate in this area.
Right. That's very inspiring. I think many people will appreciate your comments on this. And I like to joke that one of my most important contributions to the Brazilian OR community was that was to be somewhat involved with your early connections with Brazil. However, you recently took a license from PUC to assume a chair position in Montreal. So tell me more about that position.
Wow. So indeed, I have received that offer of a position in Polytechnique Montréal by the end of last year. I'm starting this year. And this position is connected to a very nice research chair, which is called Scale AI Chair in Data-Driven Supply Chains. And the whole focus of this chair is to look at the connections between the domain of combinatorial optimization and the domain of interpretable machine learning. So for example, what can you benefit from applying interpretable machine learning techniques to optimization tasks, and especially in transportation and supply chain management? How we can benefit from OR techniques to improve some models and some tasks related to interpretability, for example, simplification of some models, counterfactual explanations, transformations of prediction functions, for example. They are all very combinatorial problems, actually. You find a lot of hard combinatorics there. And then we are really wanting to put together these two domains to converge towards kind of newer generation of optimization algorithm that have some interpretability power. Like, you would be able to say to the practitioner, okay, I took this decision because of that constraint, because considering the past solution that we have, this is a common solution that you should do. Those are the kind of techniques that we try to combine to help putting decision systems in production, especially in supply chain management. And well, this opportunity to create a new research group, a chair on these domains, is just an amazing opportunity. I still seek to maintain a lot of connection with Brazil. I mean, being here in Montreal is also an opportunity to keep collaborating with my students in PUC, to bring also some excellent students from there. And I'm really looking forward to contribute to enrich these collaborations. I can have a step, I can be in the other side and still contribute to the Brazilian community. I hope so.
Yeah, I hope so too. And you're as you mentioned now, that the chair position involves AI, machine learning, logistics, supply chain, and all that. So what type of work you intend to develop during the next years regarding these topics?
So we are really looking at optimization problems, decision making in cases which are either like, for example, strategic on a very long planning horizon, and where you would, for example, need a hard combinatorial optimization problem to solve on a daily basis to estimate costs. So using learning in such context is quite intuitive, but depending on how you do it, it's going to work or not. So that's really for strategic variant of problems. We are also looking at stochastic context, where you have, for example, a learning component that is involved in some recourse function, and you want to bring some explainability to these recourses. Those are kind of two topics. Recently, in ICML, which is a big conference in machine learning, we kicked off two important papers in my viewpoint. One is about what we call born-again trees, which is a technique to compress a random forest into a single tree, which has exactly the same prediction function. And it's very funny because you do that with dynamic programming. For us, it's very like familiar tools, familiar problems. And actually for the interpretable machine learning field, this is critical to be able to simplify a model that is complex into something simpler. So I really look forward to pushing further that, making better heuristics, making something that scales even better. I'm going to put some energy and my group too on this. And then we have counterfactual explanations, which is basically, you have a model, it's going to, for example, give you credit or not. So, oh, sorry, your credit was rejected. And as a customer of a bank, and the bank tells you, well, your credit is rejected, my first answer would be, but why? If you try to ask the answer why, very often answering this question is about giving a constructive argument that tells you what you should do in order to revert the decision. So like, okay, you did not get that credit because you asked for a too large amount, or you don't have enough revenue, or you have not taken an horizon, a time span for the credit that is sufficient. So if you modify this and that, you will get the credit. But actually, this is a search problem. You are looking at the data point of a certain person, and you are trying to find another data point that this person could potentially reach with a certain set of actions that is not too far, and that reverse the decision of the prediction function. Mm-hmm. If you have a tree ensemble, like a random forest, this is very combinatorial. It's actually a very beautiful optimization problem to search. So you can apply Cplex, you can do very nice mathematical models, and then there is a whole lot of stuff that you can do to speed up things. I think these are very fascinating areas where we as OR people can really make very nice contributions. There is a lot of potential.
Yeah, I've seen some work of some researchers trying to apply some learning-based approaches to solve CVRP, for example. And sometimes they lack proper comparison, or maybe they don't consider the traditional benchmark instances, or they don't consider those that are more competitive. And as an organizer, as a co-organizer of the DIMAX Challenge, what's your opinion about this?
Well, I've been active actually on both places. I've been a reviewer from some machine learning conferences, and I often get routing papers assigned to me, and also organizing the DIMAX Challenge. My perception of the current interest for vehicle routing from the machine learning community is actually very good. There has been a renewed interest in solving VRP with machine learning techniques. And it's very stimulating to see that, well, there has been comparison with traditional OR methods, but there has been also a totally new concept of solving VRP. Instead of trying to solve it within, let's say, seconds or minutes, many methods in machine learning, especially those based on reinforcement learning, they attempted to, after training, being able to return you an answer within microsecond or millisecond. Perhaps millisecond is the more correct term in that case. So we are talking of solving 10,000 instances of vehicle routing problem within a few seconds, not solving one instance in a few minutes. It's like a lot of instances in a very short time. So these methods that have been developed for such a short amount of time, they lack the same solution quality of traditional OR techniques. But there is no method currently in the OR domain that would be as fast. In this regime, there is no existing method. So it kind of fill the gap in terms of speed that is quite useful for, let's say, real-time applications, very different context of routing application. On the other hand, one thing that is a bit sad is that these new conventions, they have kind of broken with a very long stream of comparison that we had in the vehicle routing domains. So the first reflex that machine learning researchers did when they wanted to compare with OR techniques was to take very accessible tools available on the internet, like OR tools, which is not state of the art for the VRP. It's very easy to use. It's extremely good for practical applications, but you cannot take that as a standard or as a baseline that would be representative of the OR field. It's not true at all. So I really would like to stimulate the machine learning community to take the time needed to explore the papers in the OR domain, to look at the Nagata papers or the ILNS or even ELS, the GA that we developed, more recent papers like the CISO algorithm of Jan Christiansen and Grit Vandenberg, and the Philo algorithm that Daniel Vigo and co-authors recently developed. They are all extremely good methods. And many of these methods are actually accessible. If you look on the internet, you can find on GitHub this algorithm. You can ask to the authors, you will get the code, and you will have a real baseline to compare with. So I hope that after some time, we are going to see comparisons on the same regime, which is of a few seconds, with traditional OR techniques or really modern solver for the VAP that comes from OR. And another trigger or lever that perhaps we hope to exploit to that end is the new context of the DIMAX challenge. I don't know if you have seen, but there has been a very large number of calls, like from the Rutgers University on the DIMAX group, to make an optimization challenge focused on the vehicle routing problem. And this stream of challenges, it has been instigated by David Johnson. And it's a kind of his legacy, this kind of challenges. So it's the last one in theory. It's focused on a very important problem, the VRP. Everyone is going to submit methods to compare on common benchmarks. And we really hope to see both people that traditionally conducted their research in the OR domain, and hopefully also teams that come from companies and also machine learning people. And if within the context of this challenge, we can see how this method compare to each other, that's going to be really outstanding, because we are going to create a bridge between these two areas.
Right. Yeah, I hope so. That both communities try to collaborate with one another, and try to merge whatever it's efficient and useful, both in terms of trying to advance in terms of methodological contribution, but also in terms of solving real life problems, as you mentioned. Those things are really important. So Thibaut, I know you fairly well, and I've seen you in action, and I know that you can get very focused on a particular activity, from video games to devising efficient algorithms for a particular problem or a class of problems. Have you got into trouble because of this?
Okay, yeah, that's true. So it's a kind of stereotype to reply in a job interview that your biggest drawback is to be perfectionist. Yeah. I'm really going into stereotypes here, but it's true that can be a pretty some shortcoming actually in some conditions. So let me explain a bit. When I like to do a paper, to write a paper, I don't try to achieve only a very nice methodological result or an algorithm that works and that is clearly described. I will consider that the paper is finished when it is aesthetically nice when the figures look perfect, when the text look well rounded up, that everything is symmetric. So I will really look at symmetry and aesthetics. I consider that a nice paper should also be good looking. And this helps actually reading the papers. And perhaps I do that a bit to a far too great extent. So I've published already quite a few papers, perhaps over 50, and that there has been no single paper in which I have not like fully revised the text and kind of modified good chunks of it because I preferred it my way. And that's not good because it's not productive. And sometimes you just need to accept that some people have different writing styles and being able to just delegate the writing. Well, I still want to cling to that aesthetic view, making sure that you have tightened all the knots and all the things really look good in a paper, working extensively on the figures. The figures, they convey a very visual message. The beautiful figure is so good when you look at a paper. It's worth it to invest almost half a day into a very good figure.
Definitely.
Why not?
Yeah.
I mean, it really helps. I hope to be able to continue like that. But as we know, the more we advance in career, the more we have responsibilities. We have to manage more students, more collaboration, more management things. So I'm not sure I can always do that. But one advice that I would give, if you can, really try to keep those aesthetics. We want to be self-satisfied with what we publish. A paper before that is something that you like, that you find beautiful. It's your product. So go the whole way up to something that you really like. And that will make submission process easier. Perhaps the referee will be happier to see that the papers, they are really well-rounded. And you are already on the right side of the review process. If you don't arrive with a ton of typos because you didn't have time to fix them, already the reviewer will be in a very good mood. That may put you already on the top 50% of the paper that are received in the journal actually. Then if you are in the 50% top, then accessing the 20 or 30% top will be much easier.
Yeah, absolutely. So Thibaut, it was great to have you here. I had a great time talking to you and also remembering some stories we've been through together, and also to hear your input on several subjects. So I want to thank you very, very much for doing this.
Thank you so much, Anna. It was very fun to have this conversation. I hope that people will enjoy the video. And as I told you, I'm very accessible. I love to discuss with people, share ideas. I really encourage anyone who is interested on those topics to kind of reach me either on Twitter, by email, and just see what we have in common. And even with the Scale AI chair, there is going to be a number of positions available, like PhD students, postdoc, master students. So I encourage the people that are interested to get in touch with me.
Excellent. So let's keep in touch. Até logo. Um abraço.
Um abraço. Tchau, Ana.
Bye. Ciao.
Bye.